we can test the symmetry with respect to the y-axis or the symmetry with respect to the origin. And there's also a symmetry with respect to the x-axis, although that doesn't apply to functions, and we might talk about that. Okay, why is this graph symmetric with respect to the y-axis? Why do we have this mirror image, this side mirror image? It's because, for example, 2 squared gives you 4, and then the square of negative 2 gives you 4. Now, 2 is 2 units to the right here, and negative 2 is 2 units to the left. The graph points will therefore be at equal distances to the right and left, and they have the same y value, so they'll be at the same height above the y-axis, meaning that the x equals 2 and x equals negative 2 points have this symmetry. Is this true for every pair of points? Certainly true for 1 and negative 1. You get the y values will be 1 and 1, same y value, same distance from the y-axis. So it works, and it also works for 1/2 and negative 1/2. Does it work for every possible value of x? Well, it's fairly obvious that it does, because whenever you square a negative, you get the same thing you would get if you'd squared the same number but positive. The test for symmetry is going to be just this. If the function is f of x equal x squared, I want to use the f of x notation now, is f of x equal to f of negative x? Well, it's certainly true for the squaring function. In other words, for example, is f of 2, and f of 2 is 4. In other words, if x is 2, then x squared is 2 squared, which is 4. If x is negative 2, then x squared is 4. So f of negative x would be if x is 2, f of negative x would be negative. If x is 2, negative x would be negative 2, and f of x would equal f of negative x, because the square of 2 is equal to the square of negative 2. If this is always true for every x, then you know you have symmetry, and in this case you can prove this algebraically. F of x is just equal to x squared. Whatever x is, f of x is equal to x squared, and whatever x is, f of negative x is the square of negative x, because we plugged negative x in here, we've replaced x by negative x. We've got to replace this x by negative x. Okay? And we get then negative x squared. So, is that true? And obviously it is, because we square negative x, we get positive x squared. So x squared equals x squared. The answer is yes. We conclude that we've proven the symmetry. Okay, we haven't just observed it in a few cases of a few points on the line. We've proven that it's true for all values of x. What about the cubing function? Okay, well, symmetry with respect to the origin involves, again, f of x and f of negative x, because x is some distance to the, let's assume x is positive, x is some distance to the right of the y-axis, and negative x will be the same distance to the left. Okay, well, does f of x equal f of negative x for f of x equal x cubed? And the answer is going to be no. F of x would be x cubed, f of negative x would be the cube of negative x, and that would be equal to negative x cubed. So x cubed not being equal to negative x cubed, our answer is no, it's not equal. So we don't have symmetry. And we can see we don't have symmetry with the y-axis. There's a symmetry here, but it's not a symmetry with the y-axis, which is what we test by testing whether f of x equals f of negative x. Okay, symmetry with respect to the origin means if you go on this side, you get the same value, sort of, but it's in the opposite direction. It's negative. If it's positive on this side, it's negative on this side. So just like if this is your value of x, here's our graph point, and here's our f of x. If this is negative x, then here's your graph point, and here is, I wrote that wrong. I wrote negative f of x. This should be f of negative x. Let me fix that and say it again. Again, if this is x, then here is f of x. Just go up to the graph and over. If here's negative x, then here's f of negative x. Just go up or down to the graph, down in this case, and you get f of negative x. Now, in this case, f of negative x does equal negative f of x. We can write this down, and we could plug in negative x here and do the same thing we did here with a negative in front of f of negative x. And that would take care of this negative. X cubed would equal x cubed, and we would have proven that we have this symmetry with respect to the origin.